video. In this video, we are going to discuss question number 2 from 2022 mid-examination paper. So the first question is the formation of sea and land breeze from the classic example of convection. Explain the formation of sea and the land breeze. So what is the sea breeze? Sea breeze is the wind that blows from the sea to the land during the day. Think of it like this. Sun comes up, the sun heat both land and the sea, and then land get heats very quickly than the water. So we can say land is very hot than the sea, and also hot air becomes light and rise up. It creates the lower pressure area on the land, and we know in water we have the air is cooler and heavier. It has high pressure, so the cooler air from the sea moves to fill the low pressure area of the land. So that cold wind comes from the sea to the land. Is called as the sea breeze. So we can see the answer for this question. Here, going by the definition of convection, the molecules at a higher temperature displace the ones at a lower temperature. Similarly, in the afternoon, the surface of the land near the sea is warmer and compared to the evening. Convection causes the air, which is closer to the land surface, to heat and rise. This warm air near the land is re- readily replaced by the cool air resulting in the sea breeze. So next we are going to talk about the land breeze. So what is the land breeze? Land breeze is the opposite to the sea breeze. During the night time, both land and sea gets start to cooling down. So sea is more warm than the land, and warmer air over the sea is rising up, and it creates the low pressure area over the sea. And warmer air, then the land becomes cool and it has high pressure. So the cool air from the land is moved towards the warmer sea to fill the low pressure area. So this is called as the land breeze. So let's look at the answer for this question. When it nights, the tendency of land to cool down is more. However, the air above the sea water is warm and therefore rises up. Once this air rises, it is replaced by the cool air from the land, which is commonly referred to as land breeze. So next, the second question is a steel container. It has coefficient of linear expansion 10 to the power of minus 5. Volume is 6 liter at room temperature, with volume of 6 liter filled with acetone at room temperature. The acetone's coefficient of volume expansion is this value. If the container and acetone are heated from room temperature to 60, what is the volume of spilled acetone? Note, consider the room temperature as 20. So what should we do? We need to first write down the given data. We know initial volume is 6 liter and initial temperature is the Room temperature, we know room temperature is 20 Celsius. So the T1 is equal to 20 Celsius. And the final temperature, we know the 60 Celsius. So T2 is equal to Celsius 60. And so what is now change in temperature? We called as delta T. What is the delta T? Delta T is equal to T2 divided by, T2 subtract by T1. We can get the delta T value as the 40. And for this question, we have a steel container, and inside this steel container we have acetone liquid. So for the steel container, linear expansion coefficient is equal to this value. We know linear expansion coefficient is, we identify as alpha value, and the volume expansion coefficient is equal to gamma, and gamma is equal to 3 alpha. So we need to find the gamma value. It means volume expansion coefficient for the steel container. So gamma steel is equal to 3 alpha. Alpha value is this, and we can get the volume expansion coefficient value for the steel container. And also we need to find the acetone liquid volume expansion coefficient. In here we have the coefficient of volume expansion of acetone. So we know the acetone's volume expansion coefficient value. So let's move to our problem. So before the calculate the acetone is built, we need to know the change in volume of the steel container. We can use this formula, and we know gamma is this value and initial volume is this, and the different delta T is equal to 40, and we can finally get the change in volume of the steel container as this value. So then we need to find change in volume of the acetone also. So we can use this same formula to find the change in volume of the acetone. So we know acetone here gamma value is need to be acetone's volume expansion value, and we know initial volume and delta T we know. So finally we can get the 0.360 liters for the change in volume of the acetone. So the change in volume of the acetone is greater than the steel container. So what should we do? We need to subtract this value from this value. This value from this value. So we need to find the volume of acetone spilled 0.360 liter subtract by the 0.0072 liters, then we can get the 0.35 liters as acetone is spilled. So now move to the third question. When 3 kg of water is cooled from 80 to 10, how much heat energy is lost? Specific heat of water is 4.179 joule per gram Celsius. And here also we are going to write down the given data. We know the mass of water is equal to 3 kg, but we need to convert this to gram value because the specific heat of gram water is given as the graph. So we know initial temperature is this, and also final temperature is, we know, 10. So specific heat capacity of water, we know CW. CW we know 4.179. So by using this Q summer, sorry. So by using this Q is equal to mCT, we can get the heat energy, lost heat energy value. So here is Q is the heat energy, and M is the mass, C is the specific heat of water, and the temperature, T is temperature. So we need to get the difference of the final value and initial value of the temperature. Here, then we can get the Q is equal to minus 877.59 kilojoule. So thank you for watching.